Hello everyone, welcome to session 4 of module 4, structure based or white box test design techniques. So in this session we will learn about what is code coverage and several white box testing techniques, for example statement coverage, decision coverage and some other structure based testing techniques. So let's first understand what is test coverage. So test coverage is the degree expressed as percentage to which a specified coverage item has been exercised by test suite. So for example, if you have a certain set of requirements, then how much percentage of those requirements has been covered by the number of test cases that you have executed. So that calculated as a percentage is known as test coverage. So it's a degree expressed as percentage to which specified coverage item has been exercised by test suite. So the formula to calculate coverage is number of coverage items exercised divided by total number of coverage items into 100. So that's the formula to calculate coverage. So whatever numbers of the number of the coverage items have been exercised till now, and suppose the total coverage items are 100, you have 100 requirements, and the requirements that have been exercised till now are say 80. So 80 by 100 into 100. So 80% coverage has been done. Then 100% coverage does not mean 100% tested, because coverage techniques measure only one dimension of multiple dimensions. So there are multiple dimensions of coverage. So 100% coverage of one dimension doesn't mean that your software is 100% tested. For example, 100% coverage of requirements doesn't mean your software is 100% tested, because there are many non-functional testing that needs to be done as well. So there are many aspects of software testing. So what are the types of coverage? So coverage can be measured at component testing, integration testing, system testing, or acceptance testing level. It can be measured at any test level. Then at component testing level, coverage items may be the statement or decision coverage. So at component or unit level, your coverage item may be statement or decision coverage. At integration level, the coverage items are the interfaces or interactions with other software or system. And at acceptance testing level, coverage items may be requirements, menu items, or business transactions, or end user scenarios. So what are the other types of coverage? So coverage of each specification based technique can also be measured. So for example, you have some specification based techniques, for example equivalence partitioning, boundary value analysis, decision table. So what are the types of coverage for those? So like for equivalence partitioning, percentage of equivalence partition exercised. For boundary value analysis, percentage of boundaries exercised. Then for decision tables, percentage of business rules that have been covered or completed by the test cases. Then is in state transition table, the percentage of states visited, percentage of valid and invalid transitions exercised by the test suite, by the number of test cases that you have executed. So these are some of the coverage of each specification technique that you can measure. So how to measure the coverage? So the first step is to decide on the coverage item to be counted. So first thing is to decide what you want to count. What is the coverage item that you want to count? The second thing is to count the structural elements or items. So second thing is you need to count the structural element or the items that needs to be covered. So that total calculation, total count of the coverage items need to be there in the first place. Then you need to instrument the code. So basically in white box testing, your code coverage or the coverage measure is mostly done by the tools. So tools are intrusive in nature, and you can instrument the code in order to find the coverage of elements or items. So third step is to instrument the code, and then you run the tests for which the coverage measurement is required. So you run the test against the instrumented code and for which you require the coverage measurement. And then finally, using the output from the instrumentation, you determine the percentage of items that have been exercised. So these are simple steps that are done to measure the coverage of items. So what is statement coverage and statement testing? So statement coverage is also known as line coverage. The formula to calculate statement coverage is statement coverage is equal to number of statements exercised upon total number of statements into hundreds. Formula is pretty simple. It's similar to coverage, the generic formula. So statement coverage is also known as line coverage. It is basically the coverage of the number of statements in the code when you the number of statements of code exercised when you execute your test suite. So suppose your test suite has 100 test cases. Once you execute all those 100 test cases, how many line of codes have been affected by executing those 100 test cases? That's known as statement coverage. And percentage of statement coverage can be calculated using the formula. Then studies in software industry have shown that black box testing may actually achieve only 60% to 70% statement coverage. This leaves around 25 to 40% of the statements untested. So with black box techniques, it has been seen that it doesn't depend how effective your test cases are, the black box testing test cases are. It has always been seen that the statement coverage is not always 100%. It's much less than that in black box test design technique. So that is why requirement for statement coverage and statement testing is there, and that is why you need to do white box testing along with the black box test techniques. So let's take an example of statement coverage. To illustrate the principles of code coverage, I'll take just a simple pseudocode. It's not specific to any programming language, and it's just a pseudocode, dummy code. So the code is, we are reading a value, then read x, read y, and then if x greater than y, then we are printing a statement and just ending. So in this case, let's see how we can achieve 100% statement coverage. So in this case, in this pseudocode, you can achieve 100% statement coverage with just one test case. So if you set x to 10 and y to 5, or any value of x greater than y, all the statements will get executed. So it will read a value for x, read value for y, it will come to this line, it will execute this line as well, then it will print x is greater than y, and then end. So all the lines of code will get exercised with just one test case. So you'll get 100% coverage, statement coverage in this scenario. Then what is decision coverage and decision testing? So whenever there are two or more possible exits from the statement, for example, if statement, do while, or case statement, whenever there are two possible exits and you test those decisions, because there are two exits. One is either true or false. So whenever you are testing these two outcomes, it is known as decision testing. So decision coverage ensures that each outcome, that is true and false, of control statement has been executed at least once. So decision coverage ensures that your decision outcome, true and false, have been executed at least once. Then the formula to calculate decision coverage is same number of decision outcomes that have been executed upon total number of decision outcomes in the software into 100. So that's the formula to calculate decision coverage. And research in industries have shown that even if functional testing has been done, it only achieves 40 to 60% decision coverage. So black box testing doesn't achieve 100% of decision coverage. Then decision coverage is stronger than statement coverage, and it requires more test cases to achieve 100% decision coverage. So decision coverage is stronger than statement coverage, and you require more number of test cases to achieve 100% decision coverage. So let's take an example to understand decision coverage and decision testing. So we have taken the same pseudocode. We are reading two values. If x is greater than y, we are printing a statement and then just ending. So to get 100% of statement coverage, there was just one test case sufficient to exercise all the statements of this code. But in order to get a decision coverage, you won't be able to achieve 100% decision coverage by this test case, because it checks that x is greater than y, which is true, and then it passes that. So only for the if condition, only true decision has been exercised and false has not been exercised. So in order to do 100% decision coverage, you need to exercise false condition as well. So for that, you need a value of x which is less than y. So the final test set for 100% decision coverage will be, there will be another test case in which value of x will be less than y, and then you will be able to achieve 100% decision coverage. So decision coverage is also known as branch coverage. Then 100% decision coverage guarantees 100% statement coverage, but 100% statement coverage does not guarantee 100% decision coverage. So if 100% decision coverage is there, then you can say 100% statement coverage has been done, but it's not true vice versa. Decision coverage cannot test 100% of the software code. So these techniques are useful for specific types of tests. So the types of test techniques and combination of test techniques should be chosen very wisely, and mix and match of those test techniques should be done to achieve best possible test coverage or best possible testing. So decision coverage is not suitable for any complex decision items. For example, the statement given, if a is greater than b, or a less than 10 and a plus b is equal to 20. So it's a complex decision item. Decision coverage or decision testing is not suitable for these kind of statements or items. So for more complex items, so there, as per ISTQB syllabus, these are only two techniques that you need to know a bit in detail. You should be able to identify the test cases based on the pseudocode for these two techniques, and then for there are other structure-based techniques, other complex structure-based techniques which will help you to identify decision coverage for complex decision items, for example like this. So what are the other techniques? So statement and decision coverage are two most basic coverage methods. Other more complex structure based techniques are condition coverage. So you can go to my blog and visit. I have explained all these coverage other structure based techniques there, so you can have a visit at the blog, wherein you will get condition coverage, multiple condition coverage, multiple condition decision coverage, and linear code sequence and jump testing. So for foundation level syllabus, you should just be aware of these definitions of these coverage. So to conclude, in this session we learned about what is code coverage and the white box testing techniques. Statement coverage, we learn about statement coverage, we learn about decision coverage, and then we'll also learn about some other structure based techniques that you need to be aware of. You can visit the blog and understand these techniques more there, or if you have questions you can post those questions in the discussion section and I'll answer those. Thank you.